Hey team, Sid here from DevOps Directive. I've got another episode here. It's been a quiet couple of months here. I was taking some time off to focus on family. I just had my first child, and so it's been great to spend time alone at home with her and my wife. But now we're back and bringing some new content. Today I've got a special guest, Natan Yellin from the company Robusta.dev. And we're going to get into a number of topics today, but specifically focused around monitoring and troubleshooting within Kubernetes clusters. And his company has a product that helps to do that. And so we're going to take a look at that product, what specifically it does to help enable developers and infrastructure engineers working with Kubernetes. And then at the end, we're going to spend about half an hour trying to hack on a new feature that's never been seen before for Robusta. And that's going to be to take information coming from our cluster and ask ChatGPT to help us in our debugging journey. So welcome to the show, Natan. If you want to introduce yourself, that'd be great.
Thank you. It's a pleasure for being here. And very briefly, so before starting Robusta, I was a developer for many years. I got started with open source back in high school and really loved the way as a teenager in the middle of nowhere, no one cared my age, no one cared where I was from. Just the ability to really get involved in cool projects and to learn a lot from other people. And fast forward many years, I was working as a developer with my co-founder Ari on Kubernetes security tools, and we found ourselves debugging our Kubernetes clusters a lot and wondering if there was a better way to do that. And from there, the idea for Robusta was born.
Awesome. Yeah. I think a lot of people get started with Kubernetes and you deploy your first application into it. And then all of a sudden you have 10 different applications or more, and you're trying to figure out what's going on. And it can be quite overwhelming. And I think that if you're just getting started, there's all of these different places that you can look for information. And you're sort of playing detective, right? You're putting on your detective hat and trying to figure out what does this potentially cryptic error message mean? And what can I do to fix it? Is it my role as an infrastructure engineer? Is it more of an application problem? And so what Robusta does, right, I'll try to summarize it. You can correct me if I'm wrong, but it tries to take those bits of information and sort of bring together the relevant ones and put them in front of the person who needs it at the right time. And so if the logs are relevant, it'll put those there. If the CPU or memory usage is relevant, it'll bring that in as well. And so it's taking alerting systems, which may already exist in the cluster, things like Prometheus feeding to Alert Manager, and then enriching those with the additional context of something like a metrics collection or a log aggregation. Is that right?
Yeah, that's exactly right. The problem is that the data is all there. All the data you need is present in your cluster, in your logging system, in your Prometheus, in your Grafana. All the data is there to troubleshoot the issue you have. But we're all too busy with a million things to do. So if I have to start Googling and then start digging for a specific issue, my own personal experience, I often end up only looking at the issues that are critical or that I absolutely know I need to deal with. And then stuff gets ignored just because I don't have the time to go and look at each one properly. And what we're doing is we're just pulling that data into one place. So for example, if you have a pod that it had a crash loop, then you want to see the logs, so we'll show you the logs. If you have a pod that gets unkilled, runs out of memory, then we'll show you a graph of the memory. If you have a Java application that's using up too much memory, then we make it really easy to see like a heap dump of what's going on inside that application. So we're just pulling in all the data to make it easier to see the right stuff at the right time.
Yeah, that makes a ton of sense. And one resource that I found super helpful as I started working with Kubernetes and learning a bit more about it was actually, and I'll share my screen here, this article from an organization called Learn Kubernetes, called A Visual Guide to Troubleshooting Kubernetes Deployments. So if I'll share my screen here, we should be able to see it. And essentially, it's just massive flowchart, right? Of here are all the different types of things that could go wrong within a deployment. And those things can start at the base layer, right? Something could be wrong with the node itself or the Kubernetes control plane, and then work their way all the way to the application code itself. So someone's saying that my audio is not in sync. Maybe it's delayed a little bit. How far out of sync is it? If you leave a comment, maybe we can get that.
I can hear you fine at least, so it doesn't interrupt the flow of the conversation. But
okay. I'm just trying to see.
And hello
Let
to
me just.
Mr. Rambo, to George Tolkien, of course, Pawan, and Salvin and everyone else who's joining.
Yeah, let me pull some of these commenters on screen real quick. We've got Jonathan commenting about ChatGPT. It is very hot right now. I think it kind of took the world by storm a few weeks ago as people started to realize how much these types of systems have progressed in the last few months. I mean, people were very impressed with Copilot. I have another video on my channel where right after Copilot came out, I plugged in a few different leak code problems, easy, medium, and hard, and it just cranked out the answers in no time. And that's debatable whether it's pulling that easily because there's a bunch of open source solutions on GitHub or whether it's doing something more sophisticated, but still impressive nonetheless. We've got Mr. Fambo in the chat. Good to see you here. He's a longtime fan. I know I see him often on live streams and in the comments section. Hello to George and Pavan. Pavan's with Robusta, right? He's a developer advocate with you all?
Yep. We actually met on Twitter. He was creating all these great diagrams explaining Kubernetes concepts. And then I reached out, we collaborated a little, and next thing, I was fortunate that I managed to bring him to join the team full time.
Awesome. So I adjusted something on my end, so maybe that helped to bring my audio more in sync. If not, hopefully it's not too distracting for folks. But I'm going to jump back into this diagram here that I was describing. Let's see. Pull that off. Awesome. Yeah. So essentially, there's all these potential problems that can happen within a Kubernetes context. Of something could be wrong at the very base layer of the node that it's running on, or the control plane itself, all the way up until you have your pod running and the container is running within it, but it could be crashing at the application code level. And so this just describes all the different sort of decision points that you, as a person working with Kubernetes, start to build up like an intuition for where along this flowchart do I need to enter, and what is most likely the issue. And so now when I see an issue, I can generally quickly follow this within my head and get to describe events or look at the logs or check the metrics. But it is still jumping around into a bunch of different places. And so I think what Robusta, the thing that really interests me about Robusta is that it can help you to answer all these questions at these forks in the path without having to jump from one tool to the next, right?
Yeah, sorry, I put myself on mute just due to background noise. So yeah, that's exactly right. And one of the challenges, I think, of like just existing monitoring tools, if you look at Prometheus, if you look at graphs, one of the challenges that for the most part, we're modeling stuff as either logs, metrics, or traces. And what that means is we're modeling stuff, like if you look at a log, and that's just a log line, sometimes structured, sometimes unstructured. If you're looking at traces, and that has a very specific structure. And then if you're looking at like metrics, and you're looking at a time series database, right? So you're looking at a time series that goes up and down and does various things. You can't express in those the type of stuff that's in that flowchart, because what that flowchart is it's a decision tree. And the way that we deal with that in Robusta, and the way that people are increasingly starting to look at that with other tools as well, is okay, so you have some triggering condition at the top of that flowchart. So that triggering condition at the top of the flowchart is probably a traditional Prometheus or something based on time series or something based on the log. And then as you move down that flowchart, you need a name enough, and that lets you take decisions based on what's going on in your cluster. Because we've had this increasing explosion in complexity, right? Like if I think back about an old application that ran out of memory, it was really simple. You had to get a bigger server. But now when I have an application that's running out of memory, then it could be like there could be an umkill because of other stuff that's going on that node at the same time. If I have stuff that's overcommitted, it's no longer enough to just, like this application used up too much memory. The problem here is like that you need a bigger VM, that you need a bigger machine. It's no longer so simple. It could be that it's the limits that it's hitting. It could be that the node is overcommitted. It could be a whole lot of stuff. So to go now and to be able to say like why something occurred, then really what you're doing as a human is you're running this flowchart in your head, and then you're pulling in logs, you're pulling in traces, you're pulling in metrics and graphs and all this different stuff at different places in the flowchart. So like the idea of what we're trying to do is to kind of automate that process but to do so in an open source and transparent way. So it's not this voodoo, but it's really simple set of rules and it's showing you the right data.
Got it. Yeah. Why don't we pull up your screen and go through maybe a couple of concrete examples of the types of alerts that Prometheus might be putting out, and then what type of data gets enriched. And you mentioned a few earlier in terms of, for this type of error, you might want logs. For this other type of error, you might want metrics. Let's just pull up a couple of concrete examples and maybe walk through what those look like.
Yeah,
so I'll
sure.
switch over to your screen. There's nothing there. Let's see.
I'm sharing it right now. So let me. Is that live now?
It is live now. I see Slack.
Okay, so I'm just looking at a few specific examples here in my Slack channel. Just recent example here. So here I have an alert that fired that said QPod not ready. And with just Prometheus, if I jump over to an alert manager channel, then I would just get something like an alert that looks something like this, and it would say QPod not ready. And then I have a templated explanation with the value from the metric. But I want to see more on that. Really what I want to do is I want to cross-correlate that with other data. So what I want to do conceptually is I want to take this alert, that alert fired on a pod. I know what pod it is via the labels on the Prometheus alert. So I want to pivot now to the pod. And then from the pod, pivot to the output catalog events. I want to correlate those. So if you're thinking of this in terms of SQL, then the original error is on one table, and then I'm doing a join with the pod table. And then from the pod table, I'm doing a join with the event table for kubectl get events. And that's exactly what we've done here. That just happens automatically. And then here I can see 0 of 8 nodes are available. 8 nodes didn't match the pod's node affinity selector. And now I know the reason that this pod is in QPod not ready state, it's not because there's application error here that I should tag the application developer on and say, oh, go and look at this. This is a Kubernetes infrastructure issue. And this is because either I set the wrong entities or I set the selector wrong, or because my cluster is now out of capacity. And I also can see here that the pod didn't trigger scaled up. So if I have an autoscaler, this didn't trigger an scale up. And the concept here is okay, so we just did those 2 pivots automatically. If you're new to Kubernetes, then you won't necessarily know that you're going to do those 2 pivots where you go from the alert to the pod, and then from the pod to the Kubernetes events. And if you are used to Kubernetes, then this is still the first thing that you want to see. So why not show it to you directly in Slack?
Yeah, definitely. I think the more you work with a system within Kubernetes, the more second nature doing those joins becomes, but you still have to do them, right? Unless you have a tool that's aggregating, if these data live in disparate sources, it's still time and typing to get from one piece of one clue to the next in doing this type of debugging. And so you're showing Slack here as sort of the output. I know Robusta also supports other apps like MS Teams, and this may be a good time to talk about the separation between. There's an open source Robusta project, and I'll link the GitHub for that. And that anyone can install into their clusters and sort of get this type of Slack alerting with the enrichment built in. And then there's a SaaS product, sort of that the company Robusta runs and operates, that gives another layer of UI and intuitive debugging interface on top of what the open source project provides, right?
Yeah, that's correct. And the number one rule when you create a successful open source project is the open source has to have a standalone existence. You never want to create an open source project that's just open source in name, but it doesn't actually have a usage without the SaaS platform. So what we've done is we've taken essentially what most people want when they get started, and what makes the out-of-the-box experience for Prometheus and for Kubernetes better. And we made all of that open source. So everything here in Slack, if before this, I was sending my alerts to Slack directly via Alert Manager. Now I just forward it to Robusta that's running in cluster. And it doesn't send data out of the cluster. So that's open source. That adds on the extra data here. That's going to do the ChatGPT stuff we're going to look at later on. That adds on all the enrichments, and everything that we've seen so far is in that open source offering. And then we were a little surprised when we started the company. The original plan was we'd work on this open source for 2 years. And then after that, we would build out the SaaS offering and the enterprise offering. And what surprised us early on was that people kept saying, okay, like give me a single centralized pane of glass where I can look at all of that. And then we added on the SaaS, which is just what you'd see if you click on this investigate button. So we add on buttons to alerts like investigate, like silence. We're gonna look later on ask ChatGPT, but we make it easy to like do callbacks on different alerts. So if I click this investigate button, then that will take me over to the SaaS platform. Mm-hmm. And then over here, I can see all my clusters. So if I have like 200 clusters on here, then I can see them all in one place. And I can drill down into that. And I can see the pods that are running in all the different clusters. And I can see the CPU usage and the memory usage and so on. And it was kind of a surprise for us early on that people actually wanted this, because you already have Grafana, right? You already have Lens, you already have all of that. And what we heard from people is that they were missing, like in Grafana, they were missing the Kubernetes context. So we're not replacing Grafana, but they want, like when you start an investigation, first you want to start from the cluster, you want to start from the deployment, and start from that microservice. And then later on, look at some in-depth stuff in Grafana. You want to start from really a Kubernetes-centric point of view. And then if you look at Lens, and people say, okay, like Lens is awesome, but it's not what I want to use for production. I don't want to give kubectl access to production. And so it was an interesting journey for us, because we started out thinking we would like develop whatever SaaS offering we would develop at a much later stage, and then kind of got pulled out of us by the early adopters.
Got it. Yeah, I think that gives a pretty good overview of sort of the product and the platform. I'd love to chat maybe a little bit about the company behind it, and sort of you mentioned the key to building a successful open source company, and I'll switch back to this interview mode, is sort of having this open source offering that people want, and then adding value with the SaaS offering. How is the open source project license? It's the MIT license, right? So essentially that means anyone can do almost anything with it. Any thought there in terms of licensing if building a SaaS product on top of an open source product?
You need to have, so there are different approaches, right? One approach is called it the Sentry approach, where your entire thing is open source, and what you're giving people is the hosted version. And that works well. It's a model that could probably work for us as well. Something we think about sometimes. It's not the current model. And then the other offering is the other common model is what's called open core, where you're giving away part of the product, and then you're giving away, you're charging for like either the features that big companies care about, like single sign-on, RBAC, and so on, or you're charging for a separate but related product. And that's really how we think about it. There's two products. One of those products is open source, and it's standalone, and we try and make sure it adds on value, and it does stuff independent of like the SaaS offering, so you can take that and use that without any of the non-open source components. And then we're developing a separate product, and that's our SaaS platform. And like the hard part is to not make those two products compete with one another. Because if you have those two products competing with one another, then you have these points where you say, okay, like should I add this feature to the open source, or should I add this to the SaaS platform? And we've tried, I don't know that we'll always be successful, but we've tried very hard to try and make it that the two products almost have different value propositions. One of them is a chatbot and like an integration that gives you better data and push notifications and gathers data and does all the correlations. And the other is a single pane of glass that you would open up when you want to actively go and investigate something. So we tried hard to make the split in a way that we're not competing with ourselves. But it's something that you have to think about that, and there are always hard decisions there.
Yeah, I know. And if you look at a company like MongoDB, where they spend a long time, I forget the specific license they had, but then they found that Amazon was just cloning, or essentially using their entire code base, building a duplicate of their hosted DB product. And a few years ago, or maybe last year, they switched to a more restrictive license that prevents that sort of direct competition from a large competitor like AWS. And so obviously Robusta is a little bit smaller scale than someone like Mongo currently, but was just interested to hear your thinking on that front as you build out the company and continue to grow the system.
We've chosen to deal with the problem when it arises, which is a trade-off, because on the one hand, it's harder to deal with. Like if AWS comes around and then they start adopting it, and then they then you have to fight back, and then you make change the license, then they fork it from the previous license. So on the one hand, it's a bigger mess if you deal with it at a later stage. On the other hand, for us, we wanted to optimize on the chance that we reach that stage. Like, it's a good problem to have if AWS is cutting you at the end of the day. And it's a problem we'll be able to overcome. And I just see there's a question also from Claude. So it's not exactly the GitLab model, because we do have a component that's proprietary. I think GitLab is not open core, right? GitLab is just a hosted version of the same open source solution, right?
I'm not 100% sure on that. I think there are features that you unlock when you pay premium tier prices, but I'm not sure whether they fully exist in the open source version, and they're just locked, or if they're separate.
So maybe it's like GitLab then. I'm not sure. But regarding the self-hosting, you can self-host the UI in the SaaS product, but we do that as part of our paid plans. So if you want to just use something that's entirely running your own environment, and you don't want to pay anything as well, then I would recommend you just get started with the open source version.
That makes total sense. I see Karthi's suggestion. I did just tweet. I'm not the best live streamer, so we'll see. I just tweeted out. We're 20 minutes in, but hopefully that'll bring some additional viewers as well, which should be fun. And if you have additional questions for Natan and myself about Kubernetes and monitoring, or specifically Robusta, feel free to keep putting them in the chat, and we'll periodically check there and try and get them answered. Let's see. In terms of, I'd love to hear about, again, sort of this nuance between your team splitting their efforts between building out a open source project and building on the SaaS system. How large is your team currently?
We're currently 13 people.
13 people. What percentage of effort, and obviously this is going to be rough, and you can give us an estimate, but would you say is split between those two buckets in terms of the team's day-to-day?
So it more or less comes down to, not exactly, but it more or less is for us like back-end versus front-end resources. And that's not entirely accurate, because there's some back-end on the SaaS platform as well. But at least early on, I think we probably had a 70-30 split for the open source and for the SaaS platform, and today we're moving more towards something like 50-50.
Okay, yeah,
that
makes sense.
We were a little surprised by how fast the SaaS platform took off, which we weren't expecting. So, I mean, that...
Yeah, when did you start offering that as an option for customers?
So, probably, I'd say about a year, about 10 months ago, we probably did the first version, but didn't actually publicly offer it. It was just with close design partners. And then probably started really offering that, I'd say, half a year ago. Again, I'm guessing, I don't remember the exact timeline, about half a year ago. And then since then, I mean, it's been growing very fast.
Awesome. And then in terms of like development, like my channel is all about DevOps and how teams build software and get it to production. Like there's nuance to how you might iterate on a SaaS platform where you can easily push updates and you control the deployment, right? So you can push updates multiple times a day behind the scenes that can be completely transparent to the end user versus something like Robusta that's installed into customer clusters where if you have a release and a customer installs that into the cluster, it might be 6 months, they might never update it. And so there's obviously different ways to approach software development for those two different cases. And can you talk at all about those differences and how you approach that as a team in terms of, on the one hand, having this web UI where you control the entire backend and can do whatever you want, and on the other end, software deployed into customer environments that you have a lot less control over?
Yeah, so it's definitely a challenge. It's a challenge because sometimes you want to add stuff to the SaaS platform, but that actually requires adding stuff to the version that's running in Kubernetes as well. like imagine that you're adding on now a graph of CPU usage to the SaaS platform. Well, you have to know, like, the agent running in the cluster has to be able to expose that, right?
Yeah.
So it's always a challenge, but what we do is, we try and give you access, like we try and enable stuff selectively based on what you're running. And then if you're running a version that's too old, then we can tell you, okay, like you need to upgrade here to get access to this feature.
You could prompt in the UI, here's a new feature, you can't use it yet, go upgrade and come back.
Yeah, so maybe I'll show an example of that. Let me show an example.
Yeah, let me switch over to your screen again.
So I go over here, I think, to the job screen. Actually, let's see if I can make something quickly fail. I don't know if I have a good job that I can quickly crash. Let's see. Okay, I think I have something. Okay, we'll see if I can get that working. But let's say I go back now to the screen. Then what we'll do here is we'll show you like a list of all the different jobs that are running in your cluster. Then you can see jobs that are failing, or if you have like a bunch of different clusters, then you can see the jobs that failed on different clusters. But if you were running a version that was older that didn't know how to expose that data about jobs that were running in your cluster, then you'd see a screen that's a little bit similar to this, but instead of saying no jobs to show, you would see a screen that says something like, please update to version whatever to see the jobs.
That makes sense. That makes sense.
And then we try and give you, like, there's also an art to doing this, like with developers, how you tell people, like, what is the value that you're actually going to see? So why should you upgrade? So then we'll try and do like a screenshot, like this is what you would see if you were running that version, to at least give you an incentive to upgrade, because we know it's a hassle to go and upgrade stuff also.
Yeah, for sure. And then in addition to customers being on different versions, there's also the notion of customers writing their own custom playbooks, right? So there's a number of built-in playbooks that Robusta supports out of the box. These are the common errors you might see within Kubernetes. Then any particular customer may have a challenge or an alert type that's not supported by the built-ins, or a particular data source that's not out of the box included as an enrichment option. Do you have insight into what customers are doing on that front, either just from talking to them, or is there some sort of opt-in telemetry? Like, how do you get information about the next built-ins that you should be focusing on as a company?
We mostly rely on people telling us. So also to anyone who's listening, like, if you like something, tell us. And if you don't like something, then tell us. Or if you want something, then tell us. Because we mostly rely on it. If you're using just the open source version, then we don't know what stuff you configured or haven't configured. That stays entirely within your cluster. So we don't always know that. We hear about it when people show up in support or they ask for something. So I know a number of people have done stuff around remediations. So an example is an alert fired, and then they configure an automation that will like go and delete a certain pod or run some command to fix some company-specific issue, to do an immediate workaround for that and get production back to working. So I know a few cases there with different remediations. And then we have a built-in capability around Java troubleshooting, to like fetch a heap dump or to fetch like the stacked trace from a Java application. But out of the box, we don't set that up automatically for anything. And I think there are people who have also done work to set that up automatically. So you can say like, okay, I have a Java application that's now reached 70% of the memory usage. It's about to get unkilled, but quickly go and like grab a heap dump of it, so that before it gets unkilled the next morning, I'll be able to go and look at the heap dump that was gathered.
Yeah, so almost like you know you're about to lose the information you want, and so preemptively gather it. That's a nice idea. And then, are there any sort of unique use cases? You mentioned this remediation idea, which is interesting, where a customer probably has some piece of tech debt that they know, oh, I should fix this for real, but I also know that we have other priorities, and if I just delete that pod every 3 days, everything's fine. And so that type of knowledge, which is very specific to a particular team and a particular system that they're building, is something that really makes sense in the context of a custom playbook, because it's just not relevant for anyone else. And so because Robusta is extensible, they're able to easily build that in. Why don't we take one look at the chat? And then I know we had discussed ahead of time trying to time box. So we're at the bottom of the hour. Let's shift gears after we do a pass through the chat and try and build out that feature that we hinted at in the title to this stream, where we're going to try to take an alert from our Kubernetes cluster coming from Prometheus and ask ChatGPT to help us, right? So we now have these AI systems that can provide additional context. And so we're going to try and get that working such that we can get an alert, ask ChatGPT, and use that to enrich the alert itself. Let's see. Before we do that, I see Praneeth in the chat. Good day, good evening. I know it's evening time on the other side of the world. It's still morning time for me, so it's great to have viewers from all over the world. And then, let's see, Karthi says, we have Prometheus alerts. Why Slack MS? They're not an alerting solution. They may introduce alert fatigue. Yeah, so I'll take a stab at this, and then you can chime in. I think people have, many companies have those systems already set up, and it's very easy to hook into them with the built-in sort of application add-on architecture that they support. And so you certainly can use whatever alerting software you want. You could send it to PagerDuty. You can send it to any other sort of sync is what is the terminology that you use, right? But the Slack just makes a really nice visual, and many teams are using either Slack or MS Teams.
Yeah, so I think you have to break it down to a few parts. So first of all, like when we speak generally about destinations and sending, in Robusta we call it sync. So it could be MS Teams, it could be Slack, but it could also be AppsGenie or PagerDuty. Like our general philosophy, we meet you where you are. So if today you're using an incident management system like PagerDuty or AppsGenie, then instead of like getting stuff directly sent to Slack, we'll send it to AppsGenie or PagerDuty with that extra enrichment, with the Kubernetes events, with the data about what's firing. So we're not taking a stance necessarily that Slack or MS Teams is the right place to do it, but we're giving those as options alongside AppsGenie and PagerDuty and others. And then the second part of this is you do want to get notified somewhere. So a lot of times you'll get notified in Slack or MS Teams, but you have some level of deduping in AppsGenie or in PagerDuty. You can do some of that deduping in Prometheus as well. So ultimately you want to cut down on noise. So let's say you have an alert that fires. Maybe I can give an example here. Just give an example and share my screen. Okay, so let's say I have here, I'm just going to scroll up a little bit. I have here an alert that fired for QPod not ready, and this is like a really spammy alert, or it's a known issue. So just like I would kind of maybe acknowledge the incident in PagerDuty and other stuff we get assigned to that incident, there are also solutions just using Prometheus where you can do that as well. So I could just hit silence here, and I'm doing this now with Robusta, but the same is true also for Prometheus without Robusta. And I can say, okay, ignore this alert when it fires on Airbyte. Or ignore it when it fires on this deployment. So it really is about ultimately like how you take your alerts and how you make sure that you don't have alerts that are really spammy, you don't have stuff that's building up and causes alert fatigue. You can do that just with Prometheus silencing. You can do that with features in PagerDuty or AppsGenie. You can do it in any way. Like all of them are just tools. I think what matters more is that you have the discipline, that you're getting rid of the stuff that's noisy and you're keeping the stuff that's not noisy.
Yeah, I think you can get alert fatigue with any source. And so really dialing in the threshold for which you would want to alert on is key.
Like I've seen people who have PagerDuty with, 1,000 different incidents open at once, and that's also impossible to deal with. So I think, like in general, my approach for everything, and since I probably say more than anything else, is tools are just tools. Like what matters is the discipline that you have in setting it up properly. Definitely, if you have the budget for something like PagerDuty or AppsGenie, then it can also be very useful.
Sure. Yeah, that makes a lot of sense. So yeah, why don't we shift gears and try and bring the AI overlords into the mix?
Let's do it. Okay, so I'm
All
going to share
right.
my screen.
Yep.
I'm going to give one moment of just background and speak a little bit about architecture, and then jump right into the code. So
Yeah.
let's take just an alert here, like this alert. Okay, so there was here a pod that got killed, and then we're pulling in here the graphs to show the memory utilization. Or if I have an alert here, a pod crashed, went to crash the back off, and we're pulling in the logs here. So I want to show what's powering that under the hood, because this is the area that we're about to extend. So we have here a YAML file, and in here, we just have a set of rules. So a rule, for example, says that when there's a Prometheus alert called qpod crash looping, then pull in the logs and pull in the events. So that's like the kubectl get events output for that pod. We have something here. If I go down to the memory example, then if there's host unkill detected, it's a Prometheus alert, then pull in a graph, for example, alert graph enricher, pull in the graph of the memory on the node. And we have various stuff like this. So what we're going to do right now to get this working with ChatGPT is we're just going to add on another one of these. So I think I'm actually going to start with the YAML. Have some stuff on here. We're going to live code this, but I have some stuff I prepared in advance also. So what we're going to configure at the end is we're going to just add a new rule that looks like this. It says triggers on Prometheus alert, and the action will be the ChatGPT enricher.
And so almost every alert in this case is coming from Prometheus. So this will be on all the different messages, right? Are there are there other alerts?
Yeah, so we also take stuff from KubeWatch.
Okay.
So KubeWatch, we have our own version. I think we're now the official maintainers for that. So I don't know why that doesn't show up on GitHub. Oh, I misspelled it. Okay. My bad. Let me just jump over to the Robusta version. So KubeWatch listens to all the different events from the API server, and then we use that, we feed that into Robusta, and then we can listen to stuff like a job failed, for example. We can listen to pod crashing. So a lot of times you can look at stuff either way. Like if you're thinking of a job that failed, then either you listen to the Prometheus metric, like the number of failed jobs, and say that's greater than 1. Then you have to deaggregate, take that 1 and turn it back into the actual job that failed. Or you can listen to the discrete event, like, okay, on the job failing in Kubernetes, then go and take this action. And we support both methods of that.
Got it.
But what we're going to do right now will only support Prometheus alerts.
Sure.
And this is just the wiring. That's the part that Robusta is giving. Doing the wiring, saying like, okay, take this trigger and then wire it up to this action. And then that's also wired up to destination like Slack or MS Teams. It'll just use the default one that's configured.
Yep, and just for people who aren't familiar with Helm, this is a values file that gets passed into Helm, and then those get templated into various portions in the Kubernetes deployments and resources. And so, as Natan's saying, this is just the wiring. We're going to create something called the ChatGPT enricher that Robusta then knows how to call, and within that is all the details of actually going off and sending that API request and getting the details back and enriching the message that's going to get forwarded along to Slack.
Exactly. Yeah. So let's jump in and do it. I think enough prep. So let me just zoom in a little. And what I'm going to do is I just have here the template without anything specific to Robusta, but just for ChatGPT. So I wrote here in Python a function that says get ChatGPT results. And we're taking in here an OpenAPI key that I just put in a different file. Sorry, OpenAI key that I put in a different file so it wouldn't be on screen. You can generate that for free on the OpenAI website. And
you may have flashed it when you hovered, so we'll go ahead and rotate that after.
Oh, okay. Sorry. Yeah, I may have flashed that.
No, it's all good. I just wanted to warn you.
Okay. Thank you.
The IDE is being too smart for us.
Yeah, PyCharm is being too smart. I know Arik is there listening, so I'm sorry, Arik, you're going to have to rotate that, but don't do it just yet before the demo. And then what you do afterwards is we're just calling the OpenAI function. So I'm calling OpenAI that completion, alert.create. And then you have to give it various technical parameters, just saying which version of ChatGPT you want to use. What's interesting, by the way, about the ChatGPT is it's actually based on the GitHub stuff. It's based on the GitHub Copilot stuff, if I'm not mistaken, which is what DaVinci here refers to. That's the model they trained on code. So I don't know why, but like one of the reasons why ChatGPT is actually really good at coding tasks is because it's based on that GitHub Copilot model. I don't know why they chose to base it on something that's oriented around code. Right? It's interesting.
Yeah, I mean, so GPT-3 is like the underlying model that Copilot was based on. So they're both coming out of OpenAI, and so it's just building upon this sort of the next level of that same model.
Yeah, and then we're giving it a prompt. So I thought we'd ask, how do I solve, and give the alert name on Kubernetes, but maybe we'll do explain GUM5. How do I solve alert name on Kubernetes? Or explain, should we do explain like a pirate?
Sure.
I don't know if that's going to we'll try it. How do I solve alert name on Kubernetes? And these are just two technical parameters, so we can ignore those. And then I'm getting a bunch of answers, and I'm just going and putting those all in an array and returning that array. This I should say.
Cool. So this is just vanilla. This is just raw Python. We'll call this. It'll print to console. Has nothing to do with Robusta yet.
Has nothing to do with Robusta yet, and it takes a few seconds to run. So we're also going to see that later on with Robusta. And here's the description we got. So let me just put that here. You be having a crash loop backoff problem on your Kubernetes? You need to be looking at the logs of the pod to find out what's causing the crash.
All right.
And we actually will get, I'm going to undo the pirate talk, and then we'll actually get a much better, more quality. How do I solve? Give me the bash commands to investigate alert name on Kubernetes. Maybe that will give us some more interesting results as well. And while that runs, I'm just going to now look at the Robusta part, how we take this Python code and we turn it into Robusta automation. Isn't tight. So what I'm going to do, oh, and here's the output, by the way. So it'll give me here kubectl get pods, kubectl describe pod name. This is actually decent. And I'm gonna, for the final version though, I'm just gonna revert it to how to
fix, yeah, how to investigate. Cool.
And now what we're gonna do is we're gonna just define a Python function. So we're gonna call it ChatGPT enricher, and we're gonna take here a parameter called alert. This is the currently firing alert, and I'm gonna put here Prometheus. That's too wrong. I know I did. I forgot to uncomment this import. Okay, I'm importing now from the Robusta API. Doing a wildcard import, which I shouldn't do, but forgive me this once. And I'm just going to call this Prometheus Kubernetes alert. And now this function takes as a parameter that Kubernetes, that Prometheus alert on Kubernetes. And now right here, I have access to everything about that. So I can access the alert name. I can access alert dot pod, and I can get the associated pod with that alert. We use the labels to map this directly onto the relevant pod. If there was a deployment there, I can access the deployment. I can access the job if it's another in the Kubernetes job. So let's say take the pod, then I can access all the different YAML fields here. So I can access metadata, I can access the pod spec. I can look up whatever I want based on the stuff that's like in the YAML in this pod right now.
Mm-hmm.
So what we're going to do in this case is I'm just going to take here alert name, and we're just going to call that function from earlier. So we're going to call ChatGPT results. We're going to pass that alert name, and now this is the response. Now all we have to do is we have to say, okay, we have data here. Like in came this alert. This function got called in every single alert that came in. So that's this alert object. And right now, we're just going to add additional data to investigate this alert. So I just go over here, I say alert.add enrichment. We're adding data. And then I'll put in here, like, let's say a markdown block. You can put in an image, I could put in various types of data, but I'll put in here markdown block. And I'll just pass in here the text. So this will be something like /n.join response. And just like that, now I've taken this alert that comes in, think of it as a pipeline. The alert came in from the trigger, and we ran the different enrichments. So this enrichment and other enrichments could have ran. And then it's going back out the pipeline to whatever destinations you configure, like Slack, MS Teams, Apps Genie, Datadog, wherever you want to send your data with the enriched alerts. And just like that, I've done this enrichment, more or less. Sorry, I think you're on mute.
Yeah, I was. I was asking, do we need to return anything, or is just modifying that alert in place enough?
We just modify the alert object. And we spoke a little earlier also about like remediations. Let's say in this case, I wanted to do something that's like a really awful idea. Like no one should ever do this, okay? Like seriously, no one should ever do this. I could say, give me the bash command to fix.
Execute it directly.
And now I could go like alert.run alert.pod.exec, and we could just run that bash command. Now, again, that's an awful idea. Please do not do this. I'm not going to commit this. We're going to delete this, forget it ever happened. You should not run like arbitrary ChatGPT output in your cluster. But you can use the same concept for predetermined responses that you thought of and you added and so on. So there are use cases for this, just not with the AI output.
We can edit the video to make it look like you're telling people to do exactly that. So.
And the other thing I'll say here is, okay, so what we did right now, like we have this alert that came in, and then you add on to that alert the extra block at the end. What we're actually going to do in the demo that I'm going to show is I'm going to show it when you click a button. So we're not going to do it automatically in every alert. We're going to do it when you click a button, I guess, to save your like OpenAI quota. So what I would do for that is I wouldn't now add on a markdown block. Or rather, I would do it a little bit like this. Okay, so we have here, like, this is the ChatGPT enricher. And then we're going to add on, like, ChatGPT button. And now we have the alert here, Prometheus Kubernetes alert. And now I'm just going to take the alert and I'm going to say add enrichment. Instead of putting on there a markdown block, I'm going to put a callback block. And then in the callback block, I just put here like a choice, callback choice, and I say, okay, call ChatGPT enricher. And
with the alert, right? We need the alert in the enricher.
Yeah, I think that. That means I need to check exactly what I'm doing there that's wrong, but I think I have to give the text for the button. So ask ChatGPT. And then, it needs to be a dictionary, I think. I think I messed it up a little bit, but you get the concept over here. I think this should be like this, maybe. That's ChatGPT. Whoops, sorry, my bad. Callback block, and then we'll pass here a dictionary, then ask ChatGPT maps. Yeah, so something like that. And then what I've done there is now we're just adding on the button, and when you click that button, then it'll go and it'll call this other playbook that we defined earlier.
And it'll replace the button with the response from the callback in the UI? In the new Slack message. Yeah. That's I guess you can't. You could edit it, but it makes sense for it to be a new one.
And all of this is completely in the open source, just to clarify. Like the data would show up in the UI as well if you're using the SaaS platform, but you don't need that for any of this to work. So let me actually go and show this. And I would also have to push this to Git repository. I should add that. So I would push this to Git repository, and then I could load it into Robusta by just adding it to the adding that Git repository into Robusta. So you would edit the Helm values for Robusta, and you would say, okay, just load it from this Git repository.
Okay, so then Robusta will, I guess, where is that webhook running that executes the enricher? In the Robusta pod?
In the Robusta pod, and that's all in cluster. So you have your Prometheus running in cluster. There's another, it forwards it to Alert Manager in cluster. And then from Alert Manager, it forwards it to Robusta in cluster. that communicates with ChatGPT, and then that sends it to Slack. And if you have a setup where you're sending everything to a centralized alert manager outside of the cluster, then we have an additional component that like relays it back to the right place and makes it work anyway. But in the normal setup with one cluster, one Prometheus in that cluster, then all of this occurred inside your cluster, except for reaching out to ChatGPT.
Yeah, let me dig in on that a little more in terms of, so that line 3 in the code block there, we're pointing it to this GitHub repo that contains that Python function with the enrichment built in. What are the limitations there? Like that gets pulled into the
That's pulled in when
the Robusta container?
Running. That is set up in the Robusta container when you start running.
And what are the limitations in terms of what libraries you can use or anything? Like, can I use any Python package? Does it have to be Python? What are the kind of guidelines there?
So you can use any Python package, and you just specify in here the requirements. So we're specifying in here that it requires OpenAI, and this is using the standard PyProject 2ML. That's the new Python packaging format. And then we use that to just install dependencies. And just to clarify, that's not happening. That's not happening like when the alert arrives. That's happening when Robusta is
Robusta starts up. Yeah.
And if you prefer, then you could bake that all into an image as well. So you could do a pre-baked version, like an image that has all this included already.
And if I define 5 different blocks like that, those each get their own container running as sidecars in the Robusta pod. They're each their own pod. I'm just trying to fully understand where that code gets run.
So all of that is running in the same Robusta pod, and we're just running that as an additional Python function. So we have a bunch of worker threads, and those receive events from Prometheus, from the Kubernetes API, from KeyWatch. They receive various events or events that you push by webhook, and then it just gets handed off to a worker that will go and will execute that. In the first version,
so there's multiple poetry environments inside of there that. So let's say I have conflicting versions in my 2 PyProject.tomls. There's 2 poetry environments that live inside that can handle that.
It's a single poetry environment, so it's a single virtual environment.
I guess what happens if you have 2 that have conflicting versions in the dependencies?
You wouldn't be able to install 2 with conflicting versions, at least not today.
Okay. And so when Robusta starts up, it would attempt to pull in those packages, and we would get probably some poetry error in the logs or something.
Yeah, that's correct.
Okay. Now I'm fully with you. I was just trying to see like how can we have arbitrary Python in the same container all at once. And I think I now understand.
Yeah, it's similar in some ways to like a function as a service, right? Like the alternative to doing this is you'd run a Lambda function, and then you would set up that Lambda function as an alert manager receiver, and then you would use that to do various stuff. So we're handling all the wiring and simplifying it. And then the reason that we don't do it in a separate pod is because then you have a cold start problem. Like either you have a lot of playbooks defined, so you're running a whole lot of pods, or you're running them on demand, but then you have a cold start problem. So in some of the clusters that people run this on, then they have like extremely, extremely high velocity with a lot of alerts and a lot of Kubernetes events and changes and stuff happening every single second, tens to hundreds per second. So for that type of scale, then you don't want to spin up a pod each time.
Yeah, that makes sense. So I think that gives an end-to-end demo of like if I want to make a custom playbook, either with new enrichments or new remediation actions, etc. Those are all the steps that would be required to do so. And so we did ChatGPT as kind of this fun example, but you could envision any action that you would want to take based on an alert or information gathering step based on that alert, and that's how you would bake it in. Is it only Python that is supported there, or are there other languages as well?
So it's only Python, but we let you provide, there's a built-in playbook where you can say, okay, run this bash command. So then you would just configure a few lines in YAML and say, run this bash command. Or you can say, run this Kubernetes job. So then you can give there any container and any job. But do you want to see this in action?
Yeah, let's see what ChatGPT has for us.
So I'm just gonna trigger a dummy Prometheus alert, and the example is all here on GitHub. So I have instructions on GitHub so that people can go and do this themselves. I'm gonna share that link with you if you want to put it in the chat.
Yeah, I'll paste it in.
And we just, this is new. There's 0 GitHub stars, 0 anything. So if you like this, please share it as well. And give us a star. And I've just simulated a dummy Prometheus alert. Because I can make something crash and wait around for an alert to fire, but I want it to be immediate. So here's the alert. And we pulled in some stuff. So I think they probably have the crash, the logs or something here that we pulled in. So this is just what it looks like. So we have here an alert for a crashing pod in the Robusta BI cluster. Now we get this button here that says Ask ChatGPT.
Let's do it.
Let's do it. So remember, the ChatGPT takes a few seconds to return a response. So we're going to have to wait probably about 10 seconds now to get the response back. And here we go. How to solve kubepod crash looping on Kubernetes. Check the pod logs. Check the pod's resource requests and limits. That's all there is to it. Should we try a different alert?
These are all reasonable suggestions as well.
When I simulate this, I can give the name of any alert. Does someone want to write in the chat, an alert to chat?
Yeah, what's your favorite alert?
The most cryptic alert. Target down is pretty annoying. Lots of people get target down and they don't know how to, and it's not so clear out of the box. So let's see what we get for target down.
And so target down is something that Prometheus is trying to scrape data from. It's unable to get those data, right? Is kind of the summary.
Yeah, I would give. I'd give it a D- on this response. What about you?
Check the cluster for issues. Check nodes. Because really, target down is going to be one of the sources that Prometheus is pulling from. So that's going to be the metric server, the Kube API, right? So there's a few specific things that you would want to look at that ChatGPT doesn't really nail here.
The answer is technically correct while not being useful in any way. That's the problem.
That's the summary of ChatGPT when it comes to highly technical questions.
Of course you should check the Kubernetes cluster for any issues, but I know I have an issue. Check the nodes, pods, and services for any errors or warnings. What else would I look at? Check the application notes, any errors or warnings. Which ones? How do I check it? Okay, let's give it one more example that Ari suggested in the chat. We'll do kubepod not ready.
Kubepod not ready.
I think we actually saw an example of that earlier. Here's an example, I think, of kubepod not ready from earlier, where there's a pod that's actually not ready, and then we pulled in here the Kubernetes events. So we'll see. And
so does not ready combine pending and some other statuses, or is it always pending?
Yeah, it's one of the default alerts from Prometheus stack. And I believe it combines pending and other stuff. Okay, check the pod status. It's okay, use kubectl get pods. Check the pod events. Arix is in the chat, it's either pending or unknown.
Pending or unknown, got it.
Not sure what unknown is though. Can ChatGPT create Terraform infrastructure code? Yeah, I think there's someone who did that, right? There's an example on GitHub somewhere of creating Terraform infrastructure code with ChatGPT. I think Firefly did something.
I have a video of Copilot, or I guess it was not Copilot, but the whatever they called before Copilot, just the model itself from OpenAI generating Pulumi code. If you want to check out that video on my channel, I can find a link for it. But this was probably 6 months ago, so I think ChatGPT has surpassed the quality or level that it was at that point in time.
Yeah. So are we all going to lose our job? What's the verdict?
Not yet, right? Because we're still here as experts, able to read this and say, oh, it's doing a good job or it's doing a bad job. And without that expertise, we would follow these 6 steps blindly and end up not much better off than we were before. So yeah, I think our jobs will change, but we're not losing them quite yet.
Yeah.
What are your thoughts?
No, I think so too. One of the problems that I've seen when I played around with ChatGPT too is it's very easy to get it to give you good sounding advice that's factually inaccurate. Like you can do, like if you ask leading questions like, why is my pod crashing because whatever, then it'll often say yes and explain why it is. The way I think about it is that it's really glorified autocomplete. Like it's generating the statistically likely answer that someone would say, but it doesn't actually understand the issue. And then the question that's interesting is whether you get to generate like all the way and scaling up the models, or whether there's a fundamental like phase shift there where you need different underlying architecture to make it work.
Yeah, I think that makes sense. And like it does, I think it does things like Copilot and ChatGPT can be very powerful if you have the context to know if the suggestions are good. And so like you can use it to generate a ton of boilerplate that otherwise would have been really annoying to deal with. Or I think one interesting use case that I've seen people do is to port from one language to another a solution. And so it does a really good job of like pasting in a blob of code from Python and telling it to output as TypeScript without modifying the underlying actual business logic. So I think that is a really interesting use case that it does a very good job of. So yeah, I think it's definitely an interesting topic. But yeah, I think we're at the top of the hour. I know you're a busy person. It's getting a little late there. I think we covered a lot of ground here. It was great to see. It's great to see Robusta in action. See the end-to-end process of what it takes to make a custom playbook, to pull in custom data from an external source. Understand a little bit about that architecture. I know I asked a bunch of questions, but I think excuse me, ended up with a better understanding of sort of how the different pieces all come together. And so that was very helpful. So thanks so much, Natan, for joining us. If there's any final questions in the chat, maybe we'll hang out for just a minute or two, and then we'll call it.
I want to also thank Ari, who isn't here right now. He wasn't able to join, but my co-founder, who also did some help, like also playing around ChatGPT and seeing this was technically possible. I know I'm often like the public face of Robusta and stuff, but by now there's like a team of 13 people who are like doing the real work while I'm just on different YouTube streams. So I do want to give credit there.
Awesome. Yeah. Thanks so much to him and to you. And barring any additional questions in the chat, I think I will end the stream. Thanks everyone for tuning in and participating and asking questions. It was great to get back to it, and looking forward to more streams and videos in the near future. All right. Take care.